Okay, our project is based on prediction of diseases from symptoms with different models. So coming to objective of this project, so the main objective of the project is to develop a model which can take the symptoms as input, and the user can predict the disease in future by the help of machine learning algorithms. So to obtain the high accuracy in detecting the disease for each algorithm we are going to use. So going to introduction of this project, can you share the slide with the with so the healthcare sector is one of the most important research issues in the modern era. Because of rapid advances in technology and data, it's difficult to keep track of such a large amount of patient data. So by the use of big data and analytics, make it easier to manage this data. Various ailments can be treated in a variety of ways all throughout the world. So machine learning is a novel way for predicting and diagnosing diseases. So the need of an easy to use and easily accessible and reliable source for disease prediction, which is low cost and low maintenance and can help a large amount of people. The objective of this prediction system is for those users who do not have testing centers available nearby, and to those who don't have access to immediate medical attention. So this prediction system can be used as the first stop for diagnosis, and can be used as an able aid for medical professionals in helping them and making their lives easier as well. Okay, Rohan, okay, go ahead.
Yeah, thank you, Afroz. From here, I will take over regarding the technical specifications of our project. The main algorithms we had used are decision tree algorithm, random forest algorithm, and naive Bayes algorithm. And the libraries we have used tkinter, which is a standard Python GUI library. When Python is paired with this tkinter, it provides a quick and straightforward approach to construct a graphical user interface. So tkinter is to build the Python GUI, and the other thing is we have used NumPy, which is the NumPy is a Python core library for scientific computing. It provides sophisticated Python utilities for dealing with diverse multidimensional arrays. It is a package for general purpose array processing. And the other thing we have used are pandas and scikit-learn. The pandas, we know that it is used for data analysis. It is most widely used as a Python package for the data analysis. It offers highly optimized performance with the backend source code written entirely in C or Python. So Python data can be analyzed in two ways, namely series and data frames. A series is a one-dimensional array defined in pandas that may store any form of data. Data frames are two-dimensional data structures in Python that are used to store data in form of rows and columns. In this project, pandas data frames are widely employed to use datasets required for training and testing the algorithms. Data frames enable working with attributes and results easier. And other thing is scikit-learn. Scikit-learn is a Python open source library that provides a wide variety of machine learning, pre-processing, cross-validation, and visualization techniques. It includes a large number of straightforward and effective tools for data mining and processing. It includes a variety of classification, regression, and clustering algorithms too, which includes support vector machine, random forest classifier, decision tree, KNN, and other things which we have used in our project. The main things are decision tree algorithm, random forest, and naive Bayes. And coming to the next slide, Chandana, can you go for the next slide? Yeah, thank you. Coming to the existing system, in this existing system, we can predict our disease with the data using machine learning algorithms. The prediction is not always accurate in this existing system. So for that, our proposed system, which we are trying to predict multiple diseases with symptoms as an input from the user. However, not all the users have same symptoms from a disease. So here we are using multiple algorithms to predict the disease. And from here, Chandana, you can take over. Thank you.
Sure, thank you. So next, we'll be talking about approach, how we made this idea come into fruition. So here we first gathered the data, which contains symptoms and diseases data. It would be in zeros and ones. Symptoms would be data of symptoms would be collected in zeros and ones, and the disease name would be as the header of the file. Followed by we did the data cleaning. Since we took the raw data, majority should be in zeros and ones for the symptoms. But yes, at some points we might see null value. So at that point we need data cleaning. So we did remove those null values and then cleansed our data. And then we provided algorithms for our model. The main 3 algorithms we have used here is like decision tree algorithm, Naive Bayes algorithm, random forest algorithm. We basically use these three major algorithms for our prediction of diseases. Then followed by with these 3 algorithms, we did build our Python GUI interface. There we provided buttons and then text boxes for the name of the patient, and then a drop down select option for the symptoms, and then button options so that the user can select which classifier they would like to choose to predict the diseases. Then followed by we get after we choose a classifier, we get our predictions and results. After getting those, we get accuracy as one of our classification metrics. So with that, we can followed by in-depth study those algorithms if we plan for future works, if we wanted to improve the accuracy of algorithm. Then implementations. As I said earlier, our data we have in zeros and ones. So we did cleanse our data. And then after cleansing, we did take 80% of data for training and then 20% of data for testing. And then we used one of the major logic here is the use pay for validation technique, which takes the machine learning classifier algorithms that we have taken and then use those to take those training data and analyze those and predict the diseases. So this is how our Python GUI we have designed, where we would be taking name of the patient and then select the symptoms for the disease that patient is suffering, and then use prediction options to select the prediction of diseases. And then results we would be getting here. You can see I did select prediction 1 and prediction 2. It shows both hepatitis C, and for prediction 3 it shows typhoid. That's how our model works here. Here I would show you one live demonstration of how our model works. Here you can see name of the patient. I'll just type random something like John. And then I'll be selecting my symptoms from the list of symptoms I have predefined earlier. Let me just select something in random. So, so I did select 5 symptoms for a disease, and then I used my first prediction. It shows hypertension, and then I select my second. It shows typhoid, and then my third. It shows typhoid. So not always the predictions we get of the disease we get is accurate. Since the accuracy of the model that we have built is on an average of these 3 classifiers, it's up to 93%. So you can see there is a 7% of error rate here. So sometimes all the 3 might show a same prediction. Sometimes all the 3 might show a different prediction. It goes something like that. We can reset the inputs and test with some other symptoms, and then check how we would be predicting diseases for some other symptoms. Now let me just type something in random here. And then I'm selecting pretty random symptoms so that you can see how chances of how each classifier predicts a disease. See, here you can see that all the 3 classifiers did predict different diseases. So not always this predictor shows the correct, accurate disease, but sometimes it may go wrong, which is in return the error rate is 7%. But we are trying to improve the accuracy of the classifier with more data, and then trying to achieve greater accuracy rate in our future works. So this is how our Python GUI works. And then in the results we get here, this is how our training data looks. Here you can see which is in forms of 1s and 0s and name of disease. You can see here. This would be some a graph, a scatter plot graph, how our data looks. Here you can see in just in a form of table, but here you can see it in a scatter plot table. At the end, we can see the predictions. This is how our predictions look. For the just see for the recent prediction that I did, it shows typhoid, hepatitis E, and hepatitis E. See, for decision tree, it shows hepatitis E, and then for random forest, it shows hepatitis E. But for navy bias, it shows typhoid, which is like different. Different symptoms might vary. Different predictions, and then we have to note one more point here, which is that not every person experiences the same symptoms for the same disease. So here that might vary the prediction of diseases for a person. That's how our model works, and that's how we did predict the results. From here, my next partner would be taking over. Thank you.
Thank you, Chandana. There are some challenges that we have faced in our projects. Since the data set is huge, it took more time for cleaning the unwanted data. Working with a huge data set was a big task. Cleaning the unwanted data from the data set and testing it took some time. There are codes available for different models on the internet, but since our project depends on a real and huge data set, the models had to be coded respectively and trained on our data set. The GUI and the website that was built for the project took some time, and it was challenging as we have worked very less with Tkinter and web development tools. Can you go through the next slide? Future work. Here, the present model, we are using only 3 algorithms for the prediction of disease. But in the future, we plan to give the user an option to select the drop-down from the list of a number of classifiers to choose for prediction. We are also planning to add one more diseases and symptoms to the model. And can you go for the next slide? And the conclusion was we are able to achieve the 93% accuracy on an average. We set out to develop a system that can forecast disease based on symptoms provided to it. A system like this can cut the amount of time people spend in hospital emergency rooms and lower the workload on medical staff. Here, we are successful in development such a system employing 4 different algorithms in the process. On an average, we attain 93% accuracy over here, and a system of this type can be sustainably dependable by giving its performance. Here we have included method for storing the user input which can be used in the future to build a better version. And also we were able to see how different supervised machine learning algorithms work, and analysis of the same was also done. And this gave an insight as how technologies like machine learning can help in the healthcare sector. Thank you.